Hello, this is Mark Summers from Summers Technical Services. We're going to go over some topics in our Design of Machine Elements class, in particular Mohr circle. So Mohr circle is a graphical way to represent the state of stress on a stress element. And we're going to we've already gone through the calculation of these values based on the equations we talked about in class. Now we're going to see if we can actually draw the Mohr circle based on these parameters. So up here in the top corner, you can see this is the input. This is the stuff we got from the problem statement. Sigma x, sigma y, and the shear tau xy. And these values on the left side in colors are the ones we calculated based on the equations we learned during class. So what I'm going to do is start drawing my Mohr circle. And the first thing I want to do is look at this average. Sigma average is this point right here. And you can see I've got a coordinate system. I went ahead and drew positive normal stress is to the right, positive shear stress is straight up in the y direction, and you can see the origin there. And we're going to plot these points. So this is sigma average. I'm going to put that point right there. I'm going to now do the green, which is a value called A. We calculate that as 7, so we're going to draw that line right here. This is A. 1, 2, 1, 2, 3, 4, 5, 6, 7. So that takes care of that. Now we'll take a look at B. B is this vertical distance here. 1, 2, 3, 4, 5. So that point right there is sigma x tau xy based on the original coordinate system. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over. That's sigma x, and then tau xy is 5 up. So now we've got that point. In a similar fashion, we're going to draw sigma y tau xy down here in the other corner, and sigma x from the original problem statement, sigma y was minus 4 ksi, so we'll go over 1, 2, 3, 4, and we're coming down tau yx, so it's going to have the opposite sign of tau xy. So instead of positive 5, it's going to be negative 5, so we come down 1, 2, 3, 4, 5. Now what we're going to do is draw R in this purple color, and R is going to be this radius right here. This is the radius, this is going to be the radius of our circle, like that. Now we can actually draw our circle in, and so I'm going to copy this circle I drew earlier and drag it up into place. I'm drawing all this stuff to scale, and so the circle goes through those 2 points just about like that. So now I've got my circle in place. Now we can start picking out these other values. Sigma 1, primary principal stress number 1, is this blue color. So sigma 1 is going to be right here. And that's about 11.6 KSI. You can count over from the origin. And then this brown color down here is sigma 2, which is going to be the minimum principal stress, which is right here. That's 5.6, negative 5.6 KSI. And now we can find the maximum shear stress, and that's this guy right here at the top, the maximum point curve here. So that's tau max is a y value. So the coordinate system of that point is going to be sigma average, because that red dot was sigma average, so we're going to call that sigma average. It's x value, and the y value is tau max. And we calculated these angles. These angles are going to be here. This is sigma, or phi, this angle. So it's the angle that the stress has been rotated through. And we can draw their axis. This is the x-axis. And we can draw the y-axis on this other end down here in this direction. Move this over a little bit. And y-axis will be this way. So remember these angles as you rotate the stress element, you rotate the stress element 180 degrees, you're going halfway around the circle here. So what are these other points we've got here? We've got sigma 2. I think we've got all of them. And so at this point, we can graphically see we're moving around this circle. We're rotating that stress element, and we're seeing how the principal stress has changed. So when you're up here at the top, you have maximum shear stress at the angle, and then down here, as you go toward the right, this is positive normal stress. And so this is going to be very useful when we start looking at failure modes for our parts we're designing. So failure modes, the two main ones we'll be working with are von Mises failure mode, and then maximum shear stress. And these are all failure modes that we can use based on the material type, whether it's ductile or brittle, type of loading, lots of different criteria. But depending on the criteria we're using, we'll use different parts of this stress element orientation to determine if we're going to have failure or not in our part. So that should help you get started on your homework 04B that we assigned in class today. So it's a lot of steps, but follow through and rewind the video as needed so you can go through these steps. And as you do that, depending on your starting values up here, some of your x-axis direction is going to be in this first quadrant up here, positive x, positive y. And depending on the sign, plus or minus of these values that you're given, sometimes your x-axis will be over here to the top left, negative sigma, positive tau, third quadrant or fourth quadrant. And so you have to follow these rules, make sure you get the signs correct, and your circle is going to move, your axis, your x-axis is going to be a different directional, pointing in different directions depending on what those starting values is. So pay attention to the pluses and minuses as you calculate those values and draw your Mohr circle. So that's all for now. If you got questions, stop by during office hours. Otherwise, we'll see you in class. Thanks.